Hi, everyone. Today is going to be a pretty light talk. My name is Colin Griffin. I'm a software developer. I leverage and use Docker Compose all the time, Kubernetes all the time. And my ultimate goal as a developer is getting as close to developing and operating in the environment that my workloads are deployed to as possible, and trying to eliminate that like dev to deployment workflow. You've already probably been on this track and seen several different talks to introduce you to some of the Docker concepts. I'm not going to get into a lot of that today. I'm going to make some general assumptions, and I'm really just going to try to focus on some of the practical tooling and poking around on some of these things. So as part of my schedule, I'm going to take plenty of breaks and stop for questions. The moderator will prompt me too, if need be, if you have questions in chat. But hopefully we can have a little bit of back and forth, explore some tools, and try to give you a good picture of how can we move from just using containers locally and starting fresh there, and moving into, hey, let's deploy these into Kubernetes and start playing around with Kubernetes on our local machines. So let me try to pull up my slides and get rolling. Let's share. And I'm going to try to do my best to make sure everybody can see the text. And I'm going to jump back and forth between VS Code and some other environments as well. So just ping me on chat if you're having trouble seeing. I'm not sure what the resolution is going to look like in Zoom on that side. And you may see my speaker notes. I got nothing fancy in there. It's totally fine. I hate using the presentation view, so we're just going to roll like that. So today's talk is talking about graduating from Docker to Kubernetes. Let's see, some basic outcomes that I want to work through today. I want to make sure we have a basic understanding of manual container management. So how am I going to use Docker on my local machine? What does that look like? What does that lifecycle look like? So just a refresher really there. Then graduating into a basic understanding of Kubernetes concepts. So how do they map from Docker and then into Kubernetes, and what do we call some of our resources, and what do they look like local versus deployed, and that kind of thing. I want to talk about the ability to debug containers locally. So how do I actually attach or get logs or get information from these small micro machines that are running inside of my computer. I also I want to dabble with the ability to debug containers remotely as well. A lot of that will just touch on kubectl and how kubectl works. And then I want to talk about deploying workloads into a remote cluster. That might get a little bit, we might keep that a little bit basic, because technically we've got a remote cluster running on our local machine when we run Kubernetes locally. All right, so some of my assumptions. I assume that everyone here has a basic understanding of containers, that we already have our tooling installed, and I'll talk a little bit about that. That we have a basic understanding of Linux and networking. You need to understand how machines communicate with each other. I think that's a critical step that gets bypassed in a lot of our learning and training as we become software developers. If you don't already have a good understanding of Linux, I'd encourage you to go do that. Go take a Linux course, understand basic Linux networking, what it means to SSH, and manage dependencies and some of those core fundamental things that we need to do to compose really good, solid, secure containers and workloads that will be running on those containers. Let's see. And I'm also going to assume today that we've already got some working container workloads that we can reference. This isn't intended to be a from scratch, from start. So I'm going to use some containers and things that I have locally, and we'll go through some build process there. But I'm going to assume you've done this before to a degree. All right, trying to make sure I still have my chat view before we get started. There we go. All right. So our primary tools for this talk today, and just for managing containers, there's a little bit of a rift happening in general in the container world. Docker announced that in order to use Docker Desktop, if you're not a hobbyist and you're a part of a larger company, 100 people or more, that those companies need to pay for access to Docker Desktop now and some of the other tools. I'm not necessarily against that idea. I think Docker needs to be rewarded for the work that they've done and all of the energy that they've put into containers. They didn't create and invent containers, but they certainly made it more manageable for everybody and made Docker a mainstream word. So Docker Desktop is still a really, really, really great tool today. Another tool that I am a huge fan of that's seen a lot of momentum lately since Docker has made that announcement is called Rancher Desktop. So that's an open source product by SUSE, and it does a lot of the similar things that Docker Desktop does, but it gives us a little bit more control over our environment, and it leverages more of the OCI open source container technologies and the container daemons, and it lets you choose those. It also ships pre-configured with the ability to run Kubernetes locally, as well as it has kubectl and Helm and some of those things that normally, if we were using Docker Desktop, and maybe we get a little bit of this if we flag with Kubernetes mode in Docker Desktop, but a lot of that's going to be pre-configured, and it works really, really great in Mac, Windows, WSL, and Linux environments. So that being said, my machine, my work environment, what I'm working on today is I am Windows/WSL. So I'm working in that hybrid Linux environment. I do personally now use Rancher Desktop. I've had a lot of really good luck with it, and I've dropped Docker Desktop altogether on a lot of my machines. There are other options out there, and we can talk about that in a little bit, like Podman or some of the others. But Rancher Desktop has really done a great job for me. See. So on my Rancher Desktop, I already have Kubernetes enabled. I have Traffic enabled, which is a load balancer, and we'll take a peek at that. And I have WSL integration enabled as well. Another tool that I use locally a lot as a developer is called Lens or Lens Desktop. I recommend that if you're managing multiple remote clusters and you need some convenience for shelling into your containers and debugging and getting logs, that's a great way as a developer to do that. If you're an operator or even a developer, I'd recommend, if you're thinking about deploying enterprise clusters, to look at Rancher as a solution. It's not to be confused with Rancher Desktop. It is also from SUSE, but it is a mature user interface and Kubernetes orchestrator that runs on top of base Kubernetes and doesn't make any opinionated changes to the way we interact with Kubernetes. All right, let's move along there. Okay. So in my Rancher Desktop, and I can actually pull that over, I suppose. Let's do that. All right. So I'm actually going to disable Kubernetes for the first part of this talk. So let's kill that. There are two container runtime options in Kubernetes. Let's see. Yeah, great workshops from SUSE. Thanks for pointing that out. The SUSE community is a great community. They're posting things all the time, and it is unopinionated. They're posting on base technologies and open source projects all the time. So two main container runtimes in here. A lot of people are moving to nerdctl or containerd instead of Docker, but I personally prefer using Docker because seems billions of articles out there that still leverage the Docker CLI syntax as we roll through. And so I want parity with that. I don't want to have to make that brain shift every time I see somebody else's CLI. I want to leverage those same tutorials and follow along with those. So I've selected here Dockerd or Moby, the open source project name, as my container runtime. As we set this up, and you have to do the same steps in Docker Desktop as well, I have selected WSL integration with Ubuntu. That's going to deploy some tools into Ubuntu and make sure that the network connectivity is working nicely between those. All right, so let's take a peek. So our pathway to understanding for this, how do we build a bridge between our tools in Docker and Kubernetes? And this is what we're going to roughly work through today. So I'm going to break this up into several different parts. That'll give me a little bit of time to kind of switch over some environments and get some things ready as well. First, we're going to look at that refresher. We're going to do manual container building and running using Docker run. We're going to talk about debugging. So looking at Docker logs, Docker exec. And then we'll talk about some basic containers and networking and some of those concepts. We do introduce some new networking concepts that we can do with Docker, but some folks may not have been exposed to them, like leveraging a load balancer and ingress. And I want to touch on those before we jump into Kubernetes, because those seem to be really big sticking points as people move into a new type of network architecture. So then we'll take a break there. Then we'll look at converting our Docker Compose definitions using a tool called Compose, and actually building Kubernetes manifests from there. After that, we'll look at how are we leveraging kubectl and poking around in the system with kubectl. So what does kubectl apply? How do we debug workloads? How do we shell into containers, but really in that Kubernetes environment? So what changes for us when we start running Kubernetes locally? And then we'll also start, after that, we'll start looking at what is Helm and why is Helm important in the Kubernetes world. If we have time at the end, again, I'd encourage people to ask questions as we go. We'll be able to look at some additional tools and some other things that I'd like to point out that are really, really great tools, and especially in the developer workflow space, that we just don't have time to cover in the talk today, but will be great for people to keep track of moving forward. All right. So as a quick reminder for our basic Docker flow, in a Docker machine, and this is shamelessly ripped from the Docker documentation. We've got a local CLI, a Docker CLI, or a container CLI. So in our case, it's Docker, or it's Moby, right? So it's our Docker CLI that Rancher Desktop is deployed on our local machine. That's going to communicate with a virtual machine that's running in WSL for us. That is our Docker host. So that's where our containers will be running. And then an important concept I don't think that people see enough is that a Docker registry is an important piece. We're pulling a lot of open source base images that we're layering on top of from a Docker registry, Docker Hub, which is the default. But when we move into Kubernetes, we actually need to specify where these images are coming from, and we have to interact with a Docker registry in order to pull those images if we're not just running on our local machine. And that's important for our Kubernetes manifests and those definitions. We have to tell them where to go to get those images. So I wanted to bring that up as a part of our diagram there. All right. Let's see. All right. So what I'm going to do is I'm going to switch over to our code environment, and we're going to take a peek at just some basic running and building. Now, I'm going to use our website for this. Again, we're kind of operating in the same mentality as we're preaching. So practice what we're preaching here. But I'm going to try to show that graduation from basic Docker and how we're going to do some things with Docker up on through Docker Compose, and then move on from there. All right, let's get this sucker switched over. I know I need to zoom this. Right. Right. I'm sorry for the mess. I've got a bunch of projects in here. All right. So in our projects, and I've got some extras in here. Can I remove this from our folder? I don't want to delete it. What we typically do is we manage definitions for our container runtimes in a separate GitHub repository. We like to follow more of a GitOps flow. And here I've just created one to clean things up called Krumware Stack New. And inside of Krumware Stack New, I've got some of our files and definitions. Really quick, I want to look at the Docker file for our Krumware 2, our updated website. Let's see. So our Docker file is pretty simple in this particular case. This is not our production But when you graduate into production, you're going to have to think of some new techniques and leveraging Nginx and static site builds and some of those other key pieces. But here, I'm just going to be focused on, hey, I'm a developer and I'm moving into Docker and Kubernetes, and I have a Node.js project. Maybe it's based on React. In this case, we're actually basing it on lit and rollup. We like those component-based front-end systems. So I'm starting with a base image. I'm using Node 16 Alpine because I want to strip the image of a lot of the tools and unnecessary things that come with the fat images. I don't quite need those. I'm going to specify some namespacing here or some pathing to lock down our container a little bit. And then I'm going to copy files into the container. I'm going to build my site. And then I'm going to use leverage npm run build or npm run start to kick off the build process for my container. Let's see. Let's close some of this stuff. All right. So building a container, right? I think most of you have probably done this. Essentially, what I'm going to do just for demonstration, right? If I want to build a new container images, a new container image, I need to specify the file. In this case, I'm going to use the local path and default to the Docker file, and I need to tag it with an image name. In this case, it's test. So just showing a lot of this is cached. We're actually compiling and building an image, and we're storing it on our local machine. What does it look like to actually run that image? Let's copy this. So I'm going to specify that I want to open up ports 3001. Internally in my container, I'm also specifying a port that my process runs on. So that's just why I'm mapping 3001 to my local machine for convenience. All right. Hey, Patrick just talked to him. Let's see. All right, I'll check on that real quick. All right, if we leverage, let's do localhost. If I pop this screen over here, we'll notice if I run localhost 3001, then this actually opens up our website, and this is pulling the front end from our container and actually serving it to the local machine. So I think most of us have done that with our Docker workflows. If I want to shell into a container, and I actually want to see what's going on in that container, we're going to use Docker PS to list the containers that are running at this time. What I need to do is I need to specify Docker logs, and then specify at least 3 of the characters from the container image or from the container ID. So I'm going to do 325. And that's going to show some of the version injection and other fancy things that are happening in our static site build in the front. If I want to tail those logs, so if I want to actually follow, then I'm just going to specify either -f or -- follow, and that will attach. So if I'm watching my live reload, if I want to watch for compilation problems or other things as I make my file changes, then I'll get to see those as well. One important one is that if I want to attach into the container and debug something or make file changes or check some things out, I'm going to use Docker exec. What I'm going to do is I'm going to execute a command on the container, and I'm going to do it in an interactive terminal mode. So Docker exec -it. Same thing that I did for Docker logs. I need to specify what the container definition or the container ID is. So let me actually grab that. And then since I'm in Alpine, I need to pass it a command that allows me to access a terminal. So usually it's going to be bin bash, but in Alpine, that's going to be shell, so sh. So now I've attached into the container and I can debug and do nice fancy things there. So if I want to browse, if I want to, I don't think I have nano on here. If I want to go APK add nano, then I can install nano as a dependency here. And then I can actually move into one of my files to make changes. All right, let's type exit to leave that. So from a developer workflow standpoint, a lot of times folks will deploy a container onto a VM or something, maybe an EC2 instance running in the cloud, and then manually run, trigger and run these container commands, maybe run them in detached mode. So if your environment is operating in that capacity, that's you'll want to shell into that VM and then shell into the containers themselves to see what is going on. Let's see. Some other commands that are important for my lifecycle. I actually want to stop this container. I don't want it to run and have conflicts with other things on the machine. So all I need to do there is the same thing. So docker stop. So, yeah, make sure I'm not jumping ahead. All right, I'm going to pause there for just a second. If anybody has any questions, I'm going to start moving into Compose and just switching my environment over to that, but I'm happy to take some questions for a couple of minutes.
There's one question we have. It says, if you need to know about Rancher and want hands-on, join us. Oh, there was just a comment. Okay, cool. Yeah. Thank you, Matthew. So we're good to go.
Yeah, and it really, like, SUSE has been great in the ecosystem lately. They contribute a ton. Please go over there and sign up for them. Get involved in the community there. They have great Slack channels and things as well. But mainly they're promoting open source projects all the time. That's what they do, right? So go give them some love and get involved with that community if you can. Yep, already on Compose. Let's make sure we got some stuff. All right, got our override. All right. RNV. Okay. All right, since no questions, we can just keep rolling through it. How am I doing on time, by the way? Are we done at 12:15? Or sorry, 2:15?
Yes, we're done at 2:15.
Okay, perfect. So it sounds like we're on target. So I think Docker and Compose is an important step in how we graduate through our development processes. A lot of times, and we get this question a lot as we're setting up developer workflows or working with new teams, especially when we're moving from maybe a .NET space or getting into Node for the first time, or maybe somebody's just graduated school and all they've had to do was run a simple Python process or a Node.js process, and that's really it. Maybe an integrated Next.js process. Somebody joined my same name. Interesting. That threw me off, sorry. But Docker Compose allows us really to manage multi-service, right? It introduces this concept of services and allows us to run in more of a microservices mentality. I still don't think it is true microservices. When Docker Compose and even Docker Swarm came out, we still needed more advanced tooling to support those 10, 20, 50, 100 plus workload applications and really move into that mindset of an application as the sum of its parts. It's not just the singular workload that we have running that we're trying to cram into and build this monolith with. So Docker Compose allows us to define some of those service definitions, but also do some nice things along the way for us, like introduce good networking concepts. do some heavy lifting and add DNS entries into the internal host files of these machines so that our containers can actually see and access each other privately, instead of going out to the host machine with egress and then coming back in with ingress to access another service. And that private machine-to-machine communication is an important thing that we need to consider for in our architectures. So Docker Compose is the first step into that. And what I've done here is I've defined a simple collection of different services that we're running as a part of our front end stack. A lot of these are optional, right? I really don't have to deploy Swagger when I go into production, but a lot of us, when we're thinking about developer experience and when we have basic APIs, we need to deploy something like Swagger UI to enable folks that are non-developers or maybe people at other companies or folks that need to interact with our applications to be able to see and interact and test our APIs. So that's another great workload to deploy. One of the best things about Swagger UI, in my case with containers, is I don't have to build that locally. I can just pull a Swagger UI image and then pass an environmental variable to it. And it is now pointed at my services and it's good to go. So I'm going to run this and then I'm going to poke into the anatomy a little bit. So if we go down to our console, I'm still in my Chrome Web Stack new. And I'm going to do Docker Compose. So for folks that have been around for a while, you don't have to use the hyphen anymore in Docker, and you don't have to have build kit, the build kit flag to get some of the nice newer Compose functionality. You can just do Docker space Compose, and it'll do that. So that's why and I'm going to do Docker Compose up. So if I look at my logs, I'm actually running and attaching to each of these services at the same time. So I've got my API, which is just running node server, and then my front end and Swagger and all that good stuff in the meantime. I don't really want to see all this. I don't want to work on that. So I'm going to kill this stack. And then I'm going to actually switch over into running this in detached mode. Now, point of contention, when you document and you in your stack are mentioning run requirements, I don't like specifying -d as the run requirement. I think telling somebody that you can run your stack with Docker Compose is enough. I think it's a basic knowledge set that if I want to know and run this detached, that I know how as a developer to add -d to my stack. So I actually don't recommend adding -d into your base documentation for your stack. But if I want to run in detached mode, let's do Docker Compose up and then detach, so -d. All right, so now I'm running there. In the same case, where did my fancy browser go? I can still access my localhost 3001, but because I've actually created a service for this, and let's poke into our definition here a little bit. I actually have some DNS names that I can leverage on my local machine. And if we're always worried about how do I actually use DNS and not enter port hell and try to communicate with services that way, then Docker by default will actually use the service name as the path here. So I'm going to do crumweb.docker.localhost and specify the path. And now I've actually accessed my container. Now, the important concept for networking that I wanted to show here was the ability to add container-to-container networking. Usually, you'd either have to expose to the host and then navigate through the host and have your go out to egress and back to ingress, but we actually want private communication. So Crum Web should be able to communicate privately to Crum Web API. So if I actually access Crum Web API today, so let's do Crum Web API.docker.localhost. I've specified I want to open up port 3000 for this. Then I have a simple message here that says Crum Web API says hi. Now, we mentioned before we want to shell into our containers. So let's check out what containers are running. So Docker PS is showing me that I have, looks like 4 containers running. I've got Swagger UI, Crum Web API, Crum Web 2. So let's actually attach. So I'm going to do Docker exec -it 5de cell. Now inside here, I'm going to try using curl google.com. Don't have curl. So I need to add curl. So I'm going to do apk add curl. Pretty easy. And I know these are all going to get destroyed the next time I wipe out my container. So I'm not worried about containers, dependencies hanging around. So let's curl. And I'm actually going to do from web API :3000. So we actually see that I got my output here, which is Chrome Web API hi. Now, if I actually curl from web API .docker .localhost :3000, we actually couldn't resolve the host. And that's because docker.localhost is on my computer. It's not inside the container. The container is not aware of what Docker is. It doesn't know that. And so I can't actually access that Docker host from here. And that's important for our networking concepts as we're developing. We want to make sure we access the other containers directly and not go back out to the host machine or the node as it would be in Kubernetes. All right. So I'm going to have to start jumping ahead a little bit for the sake of time, but does anyone have any questions? Yeah, Patrick, I know, you got to stay on. All right. So I want to introduce the concept of a load balancer really quick. Again, it's another thing that's skipped over by a lot of folks. So let's look at a quick little diagram here. Oh, come on, move over. Let's go. All right, so the format that we were just looking at here is that my browser or my local machine, it'll be the diagram on the left, is actually hitting my containers directly in my Docker host. But the thing that I want to do is I want to lock down and not have to expose those ports. If I have 10 or more, or it's 2 or more, but if I have 10 instances of containers that are following a particular development pattern, I don't want to have to choose and say, okay, this one's going to be port 3001, this one's going to be 3002, 3003, 3004. That gets exhausting. So we introduced a load balancer in front of our containers to do that logic for us and allow those containers to run with those common ports and not have to expose those. So in the second diagram, I'm going to introduce traffic. And traffic will actually act as a load balancer and a reverse proxy and direct traffic into my containers for me. So let's turn this guy down. All right. Let's check our Dockers. So we're going to do Docker compose down, kill our stack. If you're not running a load balancer in your local stack, run a load balancer in your local stack. All right, so anatomy of the container. One of the things that's important with the load balancer and how we actually communicate. So in Docker, at least, we're going to pass labels into Docker. That's labels are accessible from other containers. So traffic is able to actually read the configuration of another container via the labels. We need to specify and add host rules. So learn about host rules if you haven't already. Actually learn about how a request gets dissected with or by your service application to make sure it's coming from a proper host or it's getting redirected to the right place. So we're specifying a host rule of web.docker.localhost, and traffic is going to handle some of the DNS magic for us on the local machine. But I've added this, and I'm going to have to strip it back out. And we'll show this really quick with this added. So Docker compose up. Traffic, again, is an open source container. So when it gets pulled, I've actually got, I can say I depend on traffic to run so that I can access this. You notice I don't have ports exposed anymore in my environment. I'm actually redirecting traffic privately. So if I want to access it now, then I can do via my host definition, I'm going to do web.docker.localhost. And then specify, I need to specify Need to expose traffic, so I have exposed 3001 now as my port for everything. No, wait, it's web.docker.localhost. And I broke it. Let's see. Oh, I see. I think my network didn't get created. All right. There it goes. So there's my site. Same thing, I can access, for example, in this case, I'll access Swagger. And there's my Swagger endpoint as well. So everything's working, but I get to use simple DNS names. All right. Now, how do we get from here to Kubernetes? I got about 10 more minutes. All right. So I'm going to jump over to my Rancher Compose, or so my Rancher desktop, enable Kubernetes. So this is like a Docker and Docker configuration. We're going to start up a bunch of containers that'll that are actually running Kubernetes. I don't know enough about that. Rancher's just going to do it for me. We get lobby music. Any questions while we're waiting? All right, let's take a look at this. So now if I run Docker PS, let's actually open up a fresh shell for this. All right. So if we do Docker PS, we're actually going to see that there's a lot of new things here. And these are all Kubernetes related. So we actually see things are prefixed. We have Kubernetes info here. If I run kubectl, so kubectl is kind of the end-all be-all CLI for Kubernetes. So the basic command, most basic command for people to use is kubectl get all. Now, kubectl also introduces the concept of namespaces. So we can actually group things into different functional groups and kind of firewall things off from each other. And I don't have time to talk about all that stuff today. But in the meantime, we need to specify a namespace. So we're going to do kubectl get all dash all namespaces, or -a for short. So this is going to show what's actually running on this machine. We see we've got a metric server, and we actually have a load balancer already pre-installed, which is traffic, the same thing. So that's the reason I was going to need to strip those definitions out for. Now, one thing that's nice here is if I run Rancher Desktop, I can actually still use Docker Compose. And then, so we're going to stand up Docker Compose, and then we're going to see what that looks like. So let me get that back out. Compose, back over to that branch. Let's do Docker Compose up. Let's create our containers. And then let's do the same thing, kubectl all -- all namespaces. Let's see where you go. All right. Looks like we're having a machine issue today. All right. Oh, we're gonna have to skip that part. Sorry, guys. In the meantime, all right. So how do we move now if we don't want to rewrite all of our definitions for Kubernetes? So Kubernetes introduces a concept of manifest files. For the sake of time, we're not going to be able to dive as much as we want to into that. When we graduate from Compose, we can actually take our Compose definitions and we can use another tool called Compose with a K, and actually convert those Docker Compose files over into Kubernetes definitions. So I'm going to do that here. I have Compose. So it's installed. I'm going to do Compose convert. It'll use the default Docker Compose path. And it has created service definitions as well as deployments and other definitions for me. So what do these definitions look like? So welcome to YAML hell. So Kubernetes resources are all YAML definitions files by default. The way that we can deploy these is we run, instead of Docker run, we run kubectl apply, and these are actually instructions. So Kubernetes will actually go and follow these instructions and create the workloads for you on your behalf. You don't have to interact with it with a daemon that's talking to itself and orchestrating itself. So in here, we have several important areas. Compose adds some annotations. So we actually see that we've converted this with Compose, and we've actually specified a network. So it's pulled in our network name. It's pulled in some of our environmental variable definitions. And the most important thing is it is pulled in our image definitions as well. Contrary to Docker Compose, we actually need multiple definition types. We mentioned services before. We actually have to create those service definitions. So here we're actually defining the networking. The container itself is deployed in a deployment. A deployment will run containers, one or more container pods. So it'll run one or more pods, and then those pods have one or more containers. So we need to specify definitions there. But on your local machine, you can run kubectl apply on all of these files, and it will stand it up just like Docker Compose. There's also an important key piece called an ingress that we need to introduce. An ingress is going to be a definition to Kubernetes that's going to tell it how traffic needs to route from outside of your cluster and into your cluster and into a service. It's like creating a security rule or a hole. Ingresses usually have ingress classes, because you might want to choose to run Nginx, you might want to use traffic or Istio, even, or some of these others. So what you do is you create an ingress controller or add an ingress controller, and then you add an ingress definition that matches to that controller so that Istio or those other services understands how to route your traffic. That's the replacement for our labels. If we want to take a peek at Helm, so Helm is a tool that allows us to template and build these definitions. That's important to us as developers because we don't want to manually create these either with shell scripts. I guess you could automate it, but we don't want to manually create these YAML files each time we want to make a change. We also need a tool that helps us manage the life cycle of the containers. And Helm is the tool that can do that for us. Helm is a package manager. Helm is also great to look into immediately once you start working in Kubernetes, because once you get that first cluster stood up, you can leverage Helm to install all kinds of third-party tools, but not just an individual container or containers and setting those up manually and running those manually as if they were singular CLI installs and you were setting up an entire machine. You can actually set up a package of those. So Helm is going to be the tool that you're going to use most often to install dependencies in Kubernetes. So we want to actually build a Helm chart for our services. The anatomy of a Helm chart, if you use Helm create, it will create a template for you. So if we take a look at the template, we're doing variable substitution and template building and actually creating YAML files. I jump over to from web 2. What I can do is I can do Helm and install from web chart. So I've actually created an ingress, and that's opened up in traffic. Let's see, and this will load in just a sec. So I've actually deployed a nice localhost path as well without that nice Docker path, and that corresponds with my ingress. I've done that with an out-of-the-box Helm create based template. Helm has great documentation. I'd recommend reading through that. It will teach you a lot of things as you go. So we've created a deployment, horizontal pod autoscaler, an ingress, a service, and even a service account to allow us to have permissions. And I'm run out of time.
Yes, we're right on at 2:15.
Yeah. So I'd recommend, so Helm is a great place, but also take a peek at Lens and some of those other tools as well. Lens will give you a nice visual representation of the cluster and allow you to install metrics and do things there. But most importantly, manage multiple remote references to remote clusters and actually manage those clusters as well. Again, shout out to SUSE. Rancher Desktop is awesome. I'd recommend, if you really want to get observability and want to deploy your first Helm chart, do that with KubeCost. KubeCost is a great tool that allows developers and operators to get good cost visibility into their applications. But as you move into Kubernetes, you'll have a fundamental shift of, instead of thinking about top-down infrastructure, you'll be thinking about things at the application level for infrastructure. So it's an important shift. And I think, in my mind, KubeCost is a great tool to help unlock some of that shift in thinking. That's it for me today. Thank you guys so much. I'm sorry that I ran out of time and didn't go fast enough, but I hope there was some valuable stuff in this talk. Feel free to follow up with me after. Slides will be available probably a few days after the conference, as they make those available as well. And I'm always available by direct contact. So colin@krum.io. Feel free to give me a shout or find me on GitHub, Twitter, wherever the heck else. But see you later. Thanks so much.